Imagine a computer so powerful, it could crack even the toughest encryption codes in mere seconds. This is no sci-fi fantasy, but the potential reality of quantum computing. Let's take a moment to unpack this fascinating concept. At the heart of quantum computing are quantum bits, or qubits for short. Now, you're probably familiar with the classical bits in your everyday computers, which can exist in one of two states, 0 or 1. But here's where things get really interesting. Quantum bits aren't limited in this way. Thanks to a mind-bending principle known as superposition, qubits can exist in multiple states at once. Imagine you're flipping a coin. In our classical world, that coin can either be heads or tails at any given time. But in the quantum realm, it's as if the coin is both heads and tails at the same time, until you look at it. That's superposition in a nutshell. This peculiar property gives quantum computers an immense advantage over classical ones. They can perform complex calculations exponentially faster, solving problems in mere seconds that would take our best supercomputers thousands of years to crack. But it's not just about speed. Quantum computing could potentially unlock new frontiers in various fields, from medicine to artificial intelligence, and yes, even cryptography. In fact, it could revolutionize the way we approach security and data protection. But here's the rub. Just as quantum computing can enhance encryption, it can also break it. With their extraordinary power, quantum computers could crack current encryption algorithms, rendering them useless. This is a sobering thought, especially in a world where data is the new oil and cyber threats are a constant menace. So, quantum computers promise immense computational power, but what does this mean for the world of cybersecurity and encryption? It's a conundrum that has both tech enthusiasts and security experts scratching their heads. As we delve deeper into the quantum era, we'll need to find the balance between harnessing this power and safeguarding our digital world. But that's a story for our next scene. Stay tuned. In the realm of cybersecurity, encryption is our fortress against intruders. But could quantum computers become the ultimate siege weapon? To answer this question, we need to understand how encryption works. At its core, encryption relies on complex mathematical problems. These problems are designed to be easy to solve in one direction, but incredibly difficult to reverse. This is what's known as a one-way function. Consider the process of multiplying two large prime numbers. It's relatively straightforward, right? But what about the reverse? If I give you an enormous number and ask you to find the two prime numbers that multiply to form it, well, that's a whole different ballgame. It's this asymmetry that forms the basis of many modern encryption methods, including the widely used RSA encryption. Today's classical computers chug through these calculations at a steady pace. But they can't crack the code before the heat death of the universe, which is pretty handy for keeping our secrets safe. Enter quantum computers. These futuristic machines leverage the principles of quantum mechanics to process information in ways that classical computers can't. Quantum computers use quantum bits, or qubits, which, thanks to the magic of superposition, can exist in multiple states at once. This allows them to process a vast number of potential solutions simultaneously. The result? Quantum computers can, in theory, solve those tricky one-way functions in a snap, turning our secure encryption methods into wet tissue paper against a battering ram. But before you panic and start sending all your messages via carrier pigeon, there's a silver lining. The same quantum mechanics that threatens to break our encryption codes could also be used to create new, quantum-resistant encryption methods. The prospect of quantum computers cracking our encryption codes is daunting. But fear not, the cybersecurity world is not standing still. With every technological leap, there are challenges, and overcoming these challenges is what propels us forward into uncharted territories. So strap in, folks, because we're on the cusp of a new era in cybersecurity. As quantum computing technologies advance, so do efforts to develop encryption methods that can withstand their power. Welcome to the race for quantum-resistant encryption. Just as the quantum world is full of mystery and enigma, so is the pursuit of quantum-resistant encryption. This is the quest for cryptographic algorithms that, even in the face of a quantum computer's might, remain secure. Quantum computers, with their ability to process massive amounts of data and solve complex problems at speeds far surpassing those of classical computers, pose a significant threat to traditional encryption methods. In the cryptography community, there's a growing sense of urgency. With every stride in quantum computing, the need for quantum-resistant encryption becomes more pressing. But fear not, for the best minds in cryptography are on the case, exploring various approaches to this conundrum. One promising avenue of exploration is lattice-based cryptography. This method relies on the mathematical complexity of lattice problems, which involve finding the shortest path in a multidimensional grid. Even quantum computers find these problems challenging to solve, making lattice-based cryptography a potential safe haven in the quantum era. Another method being explored is code-based cryptography, which harnesses the power of error-correcting codes to create cryptographic keys. Quantum computers, despite their prowess, struggle with the randomness and complexity inherent in these codes. Then there's multivariate cryptography based on the difficulty of solving systems of multivariate equations. This method could also prove resilient to quantum attacks, adding another potential weapon to our quantum-resistant arsenal. But remember, while these methods show promise, they're still in the research and development phase. It's an ongoing race, a thrilling chase, with each cryptographic breakthrough bringing us one step closer to a quantum-resistant future. It's important to note that this race isn't just about outpacing quantum computing. It's about ensuring the security of our digital world, safeguarding our data, and preserving our privacy in the face of technological advancement. The race for quantum-resistant encryption is on. It's a thrilling chase with the future of cybersecurity hanging in the balance. Quantum computing is a double-edged sword. While it threatens current encryption methods, it could also usher in a new era of secure communication. Let's delve into the world of quantum encryption, or quantum key distribution. This fascinating technology utilizes the principles of quantum mechanics to create what is, in theory, an uncrackable encryption. Quite a mouthful, isn't it? But let's break it down. Imagine you're trying to send a secret message. In the world of classical computing, you'd use a key to encrypt this message. The receiver would then use the same key to decrypt it. The problem? If someone else gets their hands on that key, your secret is out. Now, enter quantum key distribution. This system doesn't just rely on the secrecy of a key. Instead, it harnesses the quirky behaviors of quantum particles to create a secure communication channel. Here's how it works. You send your secret message as a series of quantum states, each representing a bit of information. If an eavesdropper tries to measure these quantum states to steal your key, they'll inadvertently change them due to a fundamental rule of quantum mechanics known as Heisenberg's uncertainty principle. This change alerts you and the intended recipient to the eavesdropper's presence, and you can abandon the compromised key and start over. So you see, quantum key distribution offers a way to detect and thwart any attempts at eavesdropping. It's like a security system that not only locks your doors, but also tells you if someone so much as glances at your house. But remember, it's not all roses. Quantum encryption requires specialized equipment and conditions. There's still a long way to go before it becomes a practical solution for everyday communication. But the potential? It's undeniably exciting. So, while quantum computing poses challenges to our current encryption methods, it also holds the potential for unprecedented levels of security. This is the beauty and complexity of the quantum world. A double-edged sword that cuts through the fabric of our understanding, pushing us to rethink, reimagine, and reinvent. The quantum era is upon us, promising both incredible opportunities and formidable challenges. This adventure through the realm of quantum computing has led us to some thrilling discoveries. We've ventured into the world of quantum bits and grappled with the mind-bending principles of superposition and entanglement. We've learned that these quantum bits, or qubits, are not restrained by the binary confines of 0 and 1. Instead, they can exist in both states simultaneously, creating a vast array of computational possibilities. We've also explored the impact of quantum computing on encryption. Traditional encryption methods, which have safeguarded our data for decades, are now on shaky ground. The immense computational power of quantum machines could crack these codes in a fraction of the time it would take conventional computers. This puts our digital security at risk, and it's a risk we cannot afford to ignore. The data we hold dear, whether it's our personal information, financial transactions, or state secrets, could be exposed. But it's not all doom and gloom. The same principles that threaten current encryption methods also hold the key to future solutions. We've delved into the race for quantum-resistant encryption, a race that is as urgent as it is complex. Researchers are working tirelessly to develop new encryption methods that can withstand the power of quantum computing. These quantum-resistant algorithms are our best defense against the quantum threat, but there's more. Quantum encryption methods like quantum key distribution promise a level of security that's based on the laws of physics themselves. They could provide unbreakable encryption, ensuring our data remains secure in the quantum era. As we stand on the brink of this quantum leap, we must navigate both the risks and the opportunities it presents. We need to be prepared for the challenges, but also open to the possibilities. The quantum era could bring about a revolution in computing, transforming not just cybersecurity, but every field that relies on processing power and data analysis. The quantum era is not just about challenges, it's about innovation, progress, and an exciting future. Are you ready to embrace the quantum era?